In part 1 of Central Dogma, we will replicate the DNA. The DNA sequence enters the helicase where it separates into two single strands. The strand that goes from 3' to 5' is the leading strand. It continues by going in the DNA polymerase where it receives a new copy of the lagging strand, while the lagging strand that goes from 5' to 3' leaves the helicase with the new copy of the previous leading strand every time.
Once we have the fully copied DNA, the leading strand will enter transcription, which is the second stage of the central dogma. Here, as you see, the DNA splits up once again to travel through the RNA polymerase. That transcription factors will come into play here, encouraging the DNA to travel through the polymerase for as long as it needs to. Following the template strand, which was our original leading strand in replication, we can see that RNA can be added right here. The nucleotides are complementary to the template strand, except for the T's, which are used instead. So as we move the DNA through the RNA polymerase, the RNA that we're building gets longer and longer. Once we get to the length where the DNA is coming to the other end, we can connect it back together and it can go off to continue doing its job. Now if you look at the start codon, you'll notice that it doesn't match the first few nucleotides. This cap before the start codon allows a bit of a buffer around the protein to protect from mutations. Mutation in transcription causes the order of amino acids to in translation can render the protein useless.
Once the strand of RNA is finished, it will enter the third stage of central dogma, translation. The mRNA attaches to the small ribosomal subunit. After that, the large ribosomal subunit connects to the small ribosomal subunit. Then the tRNA that carries the amino acid called methionine enters through the A site and into the P site. Its anticodon, UAC, pairs to the codon AUG on the mRNA. This codon is called the start codon. Another tRNA goes into the A site carrying amino acid. This is determined by the corresponding anticodon to the codon on the mRNA. As the first tRNA moves into the E site, the second tRNA goes into the P site, and this is where the first and second amino acid make a peptide bond. This begins to form a polypeptide chain, also known as a protein. The first tRNA leaves the ribosome through the E site. The process continues until it reaches a stop codon. A stop codon releases the protein so it can go and do its function.